Hello everyone, my name is Eddie Britt and I'm going to work through your test for review. I'm going to try to work these problems as fast as possible. Shouldn't take too long. If you have any questions, just make sure you send me an email and I'll get back with you. Alright, so I've already logged in and let's start with problem number 1. The mean monthly electric bill for 80 residents of a local apartment complex is $148. What is the best point estimate for the mean? Well, if all you have to go on is something from a sample, then that's the best point estimate. So $148 is the best point estimate there. In a sample of 136 pipes, the average diameter was found to be 3.63 inches with a standard deviation of 0.2. Give a good point estimate for the population standard deviation of the diameter of the pipes. Again, if that's all you have to go on is this sample, then we need the standard deviation. See, with a standard deviation of 0.2. So the answer is 0.2. Alright, this problem says consider the value of t such that 0.05 of the area under the curve is to the right of t. So this is the right side. This is the only graph that has just the right side shaded. So it's got to be that one. That would only make sense. Let me see. Yeah, the area under the curve is to the right of t. Alright, let's see. Assuming degrees of freedom equals 30, select the value from the t table. So it says consider the value of t such that, okay, 0.05 of the area of the curve is to the right of t. So there's the 0.05 column, and it says degrees of freedom equals 30. So we go down here to 30 and put in the answer. Pretty sure if I select it, yeah, it put it in the blank for me. Alright. This problem, it says that Consumer Affair Investigator records the repair costs for 10 randomly selected VCRs, a sample mean of $72.82, and a standard deviation of $24.17 are consequently computed. Determine the 90% confidence interval for the mean repair cost of the VCRs. Assume the population is approximately normal. All right, so the first thing that we need to do is we need to, well, write a bunch of this stuff down, but like there's n, so I'm gonna write, so I'll just, instead of writing everything, I'll just clip it out here. So I only have to, all right, so we got n equals 10, sample mean, so x bar, 72.82, standard deviation, that's from a sample, so this is a t distribution, and we need to determine the 90% confidence interval. So that means that we need to figure out the critical t value, t sub alpha over 2. So the way that we find that, we say 1 minus 0.9 is 0.1. So we're going to put that here, 0.1. We're going to divide it by 2. So that's t sub 0.05. All right, so now we can find the critical value from the table. Let me go to the t table again. All right, so 0.05 is the middle, and then n was equal to 10, so the degrees of freedom will be 9. So I need to go to 9, and then here's my critical value, 1.833. So I'm going to use that in my formula to make my confidence interval. And remember the formula is, I believe it's x bar plus or minus t sub alpha over 2 times s divided by the square root of n. All right, so I think the first step, though, on the problem was to just put in the critical number. So let's put in the critical number first, and then I'm pretty sure it's going to ask me to do the confidence interval. Yeah, so I need to, now I'm going to do the confidence interval. I've already found my critical value, so I'm just going to use this formula here. All right, so x bar is 72.82, and that's going to be plus or minus 1.833 times s was 24.17 divided by the square root of n, and n was 10. Some of you may be thinking, how did you know it was a t-distribution and not a z-distribution? There's a couple of things. It gives us the standard deviation right here from the sample, and so when it does that, that means it's a student t-distribution. Another thing that kind of tipped me off was that the sample size was so small. Usually if it's less than 30, then it's going to be a t-distribution as well. So the formulas, you know, are super similar. It's just the way that you find the critical value that's different. All right. So I'm just going to push this on a calculator. I'm not going to use the Windows calculator. That way I can save a little time. So I'm just going to say 1.833 times 24.17, and then divide that by the square root of 10. All right, and so that's what I'm going to add and subtract from the mean. And this is money, so I'm adding and subtracting money. So I'm just going to round this to 2 decimal places, 14.01. So all I need to do is say 72.82 and add 14.01, and then 72.82 and subtract 14.01. All right, when I do that, I get the answers. Let's see. I'll put these in. So when I subtract that value, I get 58.81, so that's $58.81. And whenever I add that value, I get $86.83. All right, so this is a problem where you have to figure out the sample size. And remember, when you do these types of problems, you're going to have to always round up, because we're talking about sample size in general. We're talking about items or things. So, you know, like if we were talking about people, we can't have 500.2 people. So we would always round that up to the next integer. So it'd be 501. You know, so it doesn't matter. The normal rounding rules don't apply. You just always round it up. All right, so again, I'm just going to clip this out so I don't have to go back and forth. That way I can just do all of my work on my notepad here. All right, so it looks like this is about proportions, because I see a population proportion here. All right, so population proportion is P. It's 0.23. How large of a sample will be required in order to estimate the fraction of 10th graders reading at or below the 8th grade level at the 85% confidence level? So that's important, 85% confidence level, with at most an error of 0.02, so 0.02 error. All right, so let's see. If we look here, we start talking about populations, and we want to look at minimum sample size for populations. You can see, it's kind of hard to see that. All right. You got this formula here, you know, it's approximation. You got to take your critical Z and square it. So we've got to figure out the critical Z value for 85%. And that may or may not be on our table. We may have to just manually figure it out. Then we'll say that times P times 1 minus P, and then we'll divide that by the error squared. Okay, so we got to find that critical Z value, Z sub alpha over 2. So if it's an 85% confidence level, 1 minus 0.85 is equal to 0.15. So z sub alpha over 2. So that's going to be 0.15 divided by 2. So that's z sub, let's see, 0.075. All right. So I'll look and see if it's on the table for 85%. I usually tell students that you might want to write it on the table. That way you'll never have to look it up again, because on table B here, see they have 80% and they have 90%, 95, 98, and 99. So what we have to do, if I look it up, I'm going to look up that area. So where was my... So I'm going to look for an area closest to 0.075, and it's going to give me a negative number. But because I'm plugging it into a formula and squaring it, it's not going to matter whether I use the positive or the negative critical z-value. So if I go back to my table, and I get as close as I can to 0.075. Now that's almost 0.075, and that's as close as I can get. Negative 1.44. So whether you use the positive or the negative, it's not going to matter, again, because we're going to square it. But our value, I'm just going to put 1.44. All right, so my formula was n is approximately, it was the critical value squared times p, and p was 0.23, times 1 minus p. So that is, if you say 1 minus 0.23, that's 0.77. Yeah. And then divide by the error squared, and the error was 0.02. And I'm just going to do all that in the calculator real quick. All right, and I got 918.0864. So it doesn't matter how small this decimal is, I still have to round it up. So it's going to be 919. That's my answer. This problem says we want to know the proportion of new car buyers who prefer foreign cars. So you have a sample of 972, and of those, 204 prefer foreign over domestic. Estimate the proportion of new car buyers who prefer foreign cars. So it's just part over total. It says I can enter it as a fraction or a decimal. So I don't know. I'll just enter it as a decimal. You just say 204 divided by 972. All right, and if I round that to 3 places, I get 0.2. It'll be 210, because the third decimal place is a 9, and after that is an 8, so it'll be 0.210. All right, that was step 1. Step 2 is to create this confidence interval. All right, so I've got a couple of things that we're going to have to figure out. So we've got to use a couple formulas here. So this is, here it is right here, confidence interval for population proportion. So we need p hat, which we just figured out. That was the 0.210. Plus or minus our critical z value times this sigma sub p hat, and then here's the formula for sigma sub p hat. And since we only have, I believe we only have p hat instead of p, we'll just plug in p hat here. It'll be p hat times 1 minus p hat divided by n, and then we'll take the square root of that. And we'll take this out to several places since we're going to plug it into the formula. Don't think it's really going to matter. Let me see how many places that we're going to round this, and I'll decide how many places I'll take that out. Even though I put in the rounded answer, I'm still going to want to maybe take it out a couple places, just so I don't create too big of a margin of error. So let me just copy this over real quick. We'll write down what we have and figure out what we need. Okay, so our P that we figured out, or P hat, that's going to be, I'm going to write down the decimal, and I'm going to carry it out a little bit like that. We did round that, you know, to 0.210, but I'm just always weary about plugging in rounded values into formulas in case it creates a margin of error. Looks like 85% confidence interval. That means we need that same z-value we found before, so that is very convenient. I'm not going to go back through how to find it again, and it wasn't on the table. You know, the table has that little quick reference part, table B here, for critical z-values, and you know, it's not there. So on yours, if you have one printed out, again, you probably want to write down for 0.85, you just write down 1.44, and that way you'll have it there. But we know that our critical value, or z sub alpha over 2, is 1.44. The sample was 972, so that's what n is equal to. We need that, remember, because the formula, we needed a sigma sub p hat, okay? And that's going to be the square root of p. So I'm going to actually leave that out a couple decimal places. So 0.20987 times 1 minus p, and I can't do that in my head right now, so I'm just going to write that out. And we divide that by n, that's 972, and then take the square root of that. All right, so I'm going to plug all that in my calculator and let's see what we get. All right, so I got my sigma sub p hat to be about 0.01306. So that's how far I'm going to carry that out. All right, so now all I have to do is follow my formula. And it was p hat plus or minus z sub alpha over 2 times sigma sub p hat. All right, so that's going to be 0.20987 plus or minus 1.44 times 0.01306. So I'm going to say 1.44 times 0.01306. And I got, that is 0.01880. So I'm going to leave it like that. So now what I need to do is just add and subtract that from the 0.20987. Now this does say to round to 3 decimal places. That's why I kind of carried it out a little bit more, because I didn't want a margin of error there. But so whenever I'm going to add it and subtract it and put my answers in. So I got to round to 3 places. All right. So whenever I subtract that and round, I get 0.191. And then whenever I add that, I get 0.229. All right, determine the critical values for the confidence interval of the population variance from the given values. Round your answers to 3 decimal places. So this is the kind of crazy formula. This is with the chi-square confidence intervals. Definitely going to look up this formula. This is something that I just really don't remember or keep in my mind. And here it is right here. So I'm just going to copy this down. And it looks like this is for variance, so it depends on whether it asks me, see, all I actually want is the critical values, even though I'll put it here. So if I was doing the entire confidence interval, that's what I would want. But all it's asking me for was the critical values. This may be a two-step problem, though. No, this looks like a one-step problem. So n equals 11 and alpha equals 0.1. And remember, these things, these chi-square, since it's a variance, it's population variance. So it says determine the critical values for the population variance from the given values. Okay. So it doesn't want, I guess it would be the same critical value if we were talking about an interval for the population variance or the population standard deviation. It's just how we got the interval. We'd have to take the square root. Anyway, that's enough of me talking about that. If we scroll down here, got to get through table E. Table E is very long. So going to table G. Probably just could have pulled it up in the problem. But you can see here we have two sets. We have one on the we got one on the left side and one on the right side, because this gives you the area to the right. And since it's not symmetrical, you know, it's not like the normal curve or even the t-distribution. As your degrees of freedom gets bigger, it's symmetric. I mean, this would approach normality too, but your degrees of freedom would have to be extreme anyway. So let me look at our, what is our, so we have n equals 11, alpha equals 0.1. If you remember that formula, this is the part we're looking for. We're looking for that and that. So that chi-square value, let me double check that. So my n is 11, so degrees of freedom is 10, and alpha is 0.1. So this is alpha over 2. So it's 0.1 divided by 2. Again, n was equal to 14. So that is, I'm sorry, n was equal to 11, not 14. So that's going to be, that chi-square is going to be 0.05 if we divide that by 2. And then we have to do this thing right here. This is just 1 minus whatever I got, and this will give me the other area. So this chi-square value is going to be 1 minus 0.05, so it's 0.95. It's kind of weird how these are, but this is actually the left one, and this is actually the right one. But I'm going to look them up. N was 11, so my degrees of freedom is 10, and then I need to make sure that I look at the column with 0.05 and the column with 0.95. All right, so you got to be really careful. See, that's 0.005, so we need to look at 0.05 here, degrees of freedom 10, so that's 18.307. So 18.307 is one of my answers. And my other answer is going to be, let's go back to the table, the 0.95 here, degrees of freedom again. So it's 3.940. All right, and so that's the two answers that I enter in. I'm going to enter in the smaller one first. I really don't know if it even matters, but that's just what I'm going to do. So 3.940 and 18.307. All right, this is identifying the null and alternate hypothesis. So that's all I have to do on this problem. It says a news publisher believes that above 78% of the readers own a personal computer. So above 78%, 78% is a proportion. So it'd be P is greater than 0.78. So that's what above would mean. Now let's write the opposite of that. That will be P is less than or equal to 0.78. All right, the one that has equality, we're going to change that to equals. So we're going to make it P equals 0.78. And that is always going to be our null hypothesis, the one that has equality. Whether it's the original one you write down that has equality, this one doesn't have an equal to bar, so it doesn't have equality. Or it's the opposite. Either way, whichever one has equality, we make it equals, and that becomes the null hypothesis. All right, so now we don't have that one anymore, and this is the alternate hypothesis. So that's H sub A, or H sub 1, I've seen it called as well. So we just got to put in those two answers. But remember, the null hypothesis will always have equals. And sometimes we may have to use the keypad to find the right symbols, but since this was a proportion, I can just use P. I'm probably going to have to use it for my inequality, though, just to make sure. So P equals 0.78, and then P, and then just, let's put here P. I'm going to use this, it was above was the original, so it's greater than 0.78. All right, I know you don't have to know this, but since the alternate hypothesis is greater than, that means it's right-tailed. So if we were performing a hypothesis test here, and we would have to take that into consideration when we were making our decisions about our hypothesis. But all right, same thing here. It says a newsletter publisher believes that less than 55%. So less than 55%, just what it sounds like. Less than 0.55. The opposite of that would be greater than or equal to 0.55. The one with equality, we make that equals. So P equals 0.55. That's going to be our null hypothesis. The other one, by default, becomes our alternate hypothesis. Since it's a less than problem, or a less than in the alternate hypothesis, that means that it's a left-tailed alternative, or a left-tailed test. All right, so I'm going to type that in. P equals 0.55, and P is less than 0.55. All right. All right, same thing here. It says a newspaper publisher believes that 62% of their readers own a personal computer. Is there sufficient evidence to refute the claim? If we're trying to refute the claim, that means we're trying to say, is it not equal to 62%? So I really don't have to write this down. It's going to be equal to and not equal to. The one that's equal to is the null hypothesis. So P equals 0.62. That's the null hypothesis. The opposite of that is going to be P, and then you will have to use the keypad for this, the not equal to symbol, unless you know some other shortcut. And then that's 0.62. So remember, when you have not equals, that means it is a two-tailed test. Of course, that don't make a difference on this problem, but it eventually will as we work through some of these. All right, so I'm going to figure out this test statistic, so that means I'm going to copy this over and then make sure that I'm using the right formula, because it depends on whether I'm dealing with a mean or a population proportion, or if I have the population standard deviation or not. So all that matters when finding your test statistic. All right, this says that manufacturer claims the van has 36.9 miles per gallon rating. So that's an average. So what are we trying to figure out? It says some testing firm has been contracted to test the MPG for the van since it's believed the van has an incorrect manufacturer's MPG. It doesn't say above or below, it just says incorrect. So that means that we're going to say mu equals 36.9, and then mu is not equal to 36.9. Do I need this to work the problem out? Probably not, but I like to write it all down every time. It's good practice. See, after testing 240 vans, so n equals 240, it looks like the mean here is equal to 37.3. All right, and it says the standard deviation, assume the standard deviation is known to be 2.2. So standard deviation, it's going to be population standard deviation is 2.2. The reason why I see this as population, and I mean a z test instead of a t test, is because the sample was so big. All right, so we need to now pick out the right formula. And again, I see this as a z. So I've got to go back up to the z. Actually, let's pick out the formula and then we'll look for the critical z. All right, so here we are. Hypothesis test for a population mean, where sigma, that's the population standard deviation, is known. So x minus mu over sigma sub x bar, where sigma sub x bar is sigma divided by the square root of n. Okay, so this is our test statistic. It's going to be 37.3 minus mu was 36.9 over 2.2 divided by the square root of n, 240. So I'm just going to do this in my calculator. All right, and remember that this is it's a test statistic. It's a z test statistic. So round this to 2 decimal places. If I round mine, I get 2.82. So that's my test statistic. That's not my critical value. I didn't need that because all it asked for was the test statistic. So 2.82. All right. So this, what we basically have to figure out here, it doesn't say, it says enter the decision rule, but we need to figure out what the critical value is. And so if the critical value will tell us the place where we would have the rejection zone and the zone that's okay. And what do I mean by that? Well, depending on if it's right-tailed, left-tailed, or two-tailed, you have some rejection region. You'll have a critical value here if it's right-tailed, and then so we'll figure that out. And if your test statistic lies like in that critical zone, then you reject the null hypothesis. If it doesn't lie in that zone, meaning maybe it's smaller, it's on this side of it, then you fail to reject the null hypothesis. So all I have to do is figure out the critical value, but I need to know if this thing is, let's see, I need to know if it's if I have the standard deviation, if it's population or sample. Need to know all that kind of stuff. So I also need to know the alternate hypothesis. So let me just copy this down. So why do you need to know all that? Why do you need to know the alternate hypothesis to find? Well, remember, if it's right-tailed, left-tailed, or two-tailed, that's going to make a difference. Okay. So this says that the claim is that it would produce a mean pressure of 4.5. It's believed that the valve performs above. So that would be above is greater than. So what does that mean? If you write the opposite of that, that would be mu is less than or equal to. And then the one with equality becomes your null hypothesis. So that's H sub O, that's H sub A. All right, so since it was greater than right here, that makes it a right-tailed. I guess I got lucky when I guessed here. So this is right-tailed. So I'm trying to figure out the critical value here. That would be the number that I would use to compare the test statistic to see if the test statistic lies in the critical region or not. All right, so a lot of these tables are in your book. If it's right-tailed or left-tailed, it says the significance of 0.02 is used. If I pull up your book, I don't know, I might mess something up, but let's see if I can pull up your book real quick, and then I can show you those tables. A lot of you may have printed out something that, or maybe I handed something out or emailed you something, but I go here, hypothesis testing. All right, so you can tell right here, it's telling you like how to tell if it's two-tailed, right-tailed, left-tailed. So I'm looking for the right-tailed. See, this is the two-sided, so this is two-tailed values. I don't need that. I need the right-tailed. They make it so easy to find. This is greater than, so this is the right-tailed values that I need. So this is just going to tell me that critical value. All right, and if it's not in the chart, I can show you how to find it using our other tables. So here's the chart. It's right-tailed. Significance level is 0.02. Guess what? It's not in the chart. It should be here, but it's not. But that's okay. Never fret, because I can show you how to find it. All right, so since it's 0.02, what that means is, and I know I have it drawn over there, but I'm drawing it again here. I want the area right there to be 0.02. So I'm looking for the value in the table where I have an area of 0.02. Well, that means the area on this side is 0.98. Now, I didn't have to divide anything by 2 because it's not a two-tailed test. It's just a one-sided test. It's a one-tailed test. So the reason why I want to know that this 0.98 is on the left side is because that's the way that our tables are made. They give us the area cumulative left to right. So if I look up an area of 0.98, I'm going to get the critical value. And I bet you it's somewhere in between these two right here, because see, 0.05 is 1.645 and 0.01 is 2.33. Well, 0.02 is somewhere in between those two numbers. So I'd be willing to bet you anything it's between those two. Probably closer to 2 than anything. So we're going to look up 0.98, or as close as we can get in the table. We don't want to use any of the not this table down here, not this little table. We want to look in here and get as close to 0.98 as possible. So this is 2 10,000ths away. This is 3 10,000ths away. Well, 2 10,000ths is closer. So that's 2.05. So that would be another good thing to write down on your chart if you have one, is, you know, somewhere about right in here at the 0.02 level, we have a critical Z value of 2.05. Okay, so what does that mean? That means that the Z value right here, the critical Z value, is 2.05. So if I had to find my test statistic, if it's greater than that, that means we would reject the null hypothesis. If it's less than that, the test statistic is less than that, we fail to reject. So that's why that's so important. But the answer, regardless of how much I talk about it, is we will reject if Z is greater than 2.05. All right, this is another find the test statistic. All right, so you may be thinking, well, how is this different? I see 0.02. Well, we need to know if it's left-tailed, if it's right-tailed, if it's two-tailed. We need to know if the population standard deviation is known or unknown, because if it is unknown, it becomes a T critical t value. Okay, so I'm going to copy this down. All right, so this tells us it takes 108 hours to receive a basic driving license. A new license for training method uses computer-aided instruction has been proposed. A researcher used a technique with 110 students, and they observed they had a mean of 107. All right. Assume the standard deviation is known to be 7. A significance of 0.02 will be used to determine, so that's the significance, it will be used to determine if the technique performs differently than the traditional method. So here's the traditional method. So the claim is the traditional method, it takes 108. The opposite of that is not equal to 108. So that means this is the null, this is the alternate hypothesis. The not equal to makes this a two-tailed test or two-tailed alternative. So we're trying to find the test statistic. So we're not trying to find the critical value. We just want to find the test statistic. Excuse me. All right, so that means I need the formula of how to find the test statistic. It gave us the standard deviation. So we're just going to use this same formula here. Z equals x bar minus mu over sigma sub x bar. All right, this right here, I know I wrote down mu. It came from a sample, it looks like. So it's actually x bar. So my test statistic is going to be z equals 107, it's x bar minus mu 108 divided by sigma sub x bar. Sigma sub x bar is 7 divided by the square root of 110. So I'm going to punch that in the calculator. And I get all right, remember I got to round this thing to 2 places because it's a z value. So I get negative 1. That'll be 50. So that's the test statistic. That's not the critical value. I would need the critical value, which I'm not going to worry about because it's not what it's asking for. But if I knew the critical value, then I could see if this lies within the critical region or the rejection region. All right, but I'm just going to put in the answer. Negative 1.50. All right, here it's asking me to, again, state the null and alternate hypothesis. So what is the claim? It says it usually takes 9.1 hours, and then it says, let's keep reading, it wants to be determined if the technique performs differently than the traditional method. So it's going to be mu equals 9.1, it's going to be the null. So I don't have the mu symbol, I gotta use the keyboard. Mu equals 9.1, and then the one without equality, even though it looks like it has equality, it's a not equal to, that's a not equality, 9.1. All right. So this is asking us to find the test statistic again. All right. So let's find us another test statistic. Again, it's going to depend on whether it's a z or a t or a proportion or whatever. So it takes this long normally to receive a basic flying license. That doesn't sound very long to get a flying license, but that's okay. And then with computer-aided instruction, So we got n equals 16. They observed they had a mean of 11.4 with a standard. So the standard deviation came from the sample. That's important because that tells me it's a t-distribution. So S equals 1.6, and it says the significance level is 0.01. All right, so we're trying to find the value of the test statistic. So we just got to make sure that we find the value of the t-test statistic because we were given a sample standard deviation. All right, so here's the formula here. It's basically the same, you see. The only difference is you have S instead of sigma. So and this is the critical t value. No, I'm sorry. This is the t-test statistic. It's going to be equal to 11.4 minus 11.2 divided by 1.6 over the square root of 16. Well, we know that the square root of 16 is 4. So let's punch that in the calculator. It says around to 3 decimal places. All right, and it actually came out to be a really pretty answer. I got 0.5, so there's no rounding needed. That's my answer. All right, here again, I'm going to determine the rule for rejecting the null hypothesis. So when we're figuring out the decision rule for rejecting the null hypothesis, that's just another way of saying what's the critical value. It's going to depend on a couple of things, especially if this is a t, which it says it is. It's a t distribution here. So we have to get a critical t value, and I'll show you how to do that. It's a little different than a z. The little tables aren't there for you like they are in the section with the z values. You actually have to use the critical t value chart to do that. So if we want the critical value, we need to know a couple of things. We need to know if it's left-tailed or right-tailed or two-tailed. So it says that they want to know if it correctly works at this setting. So that's a mean weight of 410. It's believed that it's underfilling the bags. Okay, so we write underfilling would be less than 410, and then we write the opposite of that, greater than or equal to 410. The one with equality, which I've already wrote it right there, but the one with equality, this one is going to become the null hypothesis. It's going to be equal to. I'm going to erase that. So there's a null. And here's the alternate hypothesis. All right. This means it's a left-tailed. So that means that when I look up this answer, it might give me a positive answer in the t-chart, because if you look in the critical t-chart, there's no negative answers there. It might give me a positive answer, but I got to make it negative because it's left-tailed, okay, because of the less than. So we don't need anything else. We don't need a standard deviation. We just need the n is equal to 22. So the degrees of freedom is equal to 21. And then we need the level of significance. It's 0.05. All right, so now we're going to go to the critical t chart. All right, and we were at the 0.05, so that's right here in the middle. And then the degrees of freedom, let me double check, was equal to, so it'd be 21. I guess I could have looked here, 21. So I need to go down to 21 on my table. And I'm in the middle column. And 21 is 1.721. All right, but remember I told you, since it was left-tailed, I have to make it negative. If it was right-tailed, I would keep it positive. But since it's left-tailed, I have to make it negative. So my critical t value is negative 1.721. So that means that we would reject, of course, we would need to know the test statistic, but we would reject H sub O if our test statistic is less than negative 1.721. All right, here we want to find a test statistic. Okay. So we'll copy this over. Try to speed this up a little bit. I know it's kind of dragging on. A lot of these problems are the same. So the valve tested on 290 engines, and the mean, so this is from the sample, was 6.5 pounds. Assume the population variance is 1.00. We don't use variance, we use standard deviation. But the good thing is the square root of 1.00 is 1.00. All right, it says the engineers designed the valve such that it will produce a mean pressure of 6.4. It is believed that the valve does not perform to the specifications. So if I had to write everything out, it would be, I'd say equals 6.4, then not equal 6.4. This would be my H sub O, this would be my H sub A. Significance level of 0.1. I want to find the test statistic. So really all I need for the test statistic, since I know I have my population standard deviation, it's a Z. That's going to be equal to X minus mu over sigma divided by the square root of n. Okay, so that's going to be 0.1 in the numerator, and then I'm going to say times the square root of 290, and then I could divide it by 1, but that does nothing. So want to round this to two places. 1.70 is my answer. All right, on this next problem, we're going to find the p-value. So I'm going to bring up a little p-value chart for you. So before I bring up the chart, let's just write down everything that we have. Let's see what the claim is. So read through that. Valve was tested. We know that n is, this is definitely not what I was looking for. It's the next problem. All right. So we need to, let me redo this problem. Let me recopy it over. Sorry about that. We need to write down all the information, and then we will figure out, I'll show you the little p-value chart and show you how to figure it out. It's not too bad. All right. So you can see that the level's at 0.02. And it says, wants to know if there's evidence that the drug stays in the system for more than 344 minutes. So that would be mu is greater than 344. So the opposite of that is mu is less than or equal to 344. So this one will have equality. So mu equals 344. That is going to be your null hypothesis. The other is going to be your alternate hypothesis. And because of the greater than right there, that means that it's right-tailed. All right, the other information here, it says we had a sample of 81 patients, and their mean time was 348. Assume the population standard deviation is 23. The population standard deviation equals 23. All right, so let me pull up that chart. So it's kind of a small chart. I'm going to try to blow it up as much as possible so you can read through it. All right, so if you're looking for a p-value, you need to know if it's left-tailed or right-tailed. And our problem, remember, if we scroll back up, is it was right-tailed. So for right-tailed, the p-value is going to be the area to the right of the test statistic. So we have to figure out the test statistic and then use our z-score charts to find the area. Okay? And that'll be our p-value. So we need to calculate the test statistic. Now, since the population standard deviation was given, we know that it's a z. So z equals, we got x bar minus mu over sigma sub x bar, which is 23 divided by the square root of n. All right, or square root of 81, which is 9. So if I do that in a calculator, all right, remember this is a z-score. So it's 1 point, if I round, 1.57. So according to my chart, I want the area to the right of the test statistic, okay? So what I have to do is I look up 1.57 in my chart, and then I say 1 minus that answer. Because when you want area to the right, that's what you do. So you got to go back up to, this would be table B, and it was 1.57. It's a 7 column there. 1.57 right here. So 0.9418. All right. So the p-value is going to be 1 minus 0.9418. Let me do that in a calculator. All right, and I got 0.0582. So let's make sure we see how many places it says to round to, but that's the exact answer. I'd imagine it wants that. All right, so let's go here, around to 4 places. That's right, so 0.0582. All right. Hey, I like this. It's just asking what kind of test is it. So this isn't going to be bad at all. So I'm going to still copy it over. I could probably just figure it out by looking at it, but I would rather try not to skip any steps. That way I don't want you to be confused. I want you to understand what you're doing. All right. So it says that this bag is filling correctly at, so we want to know if it's filling correctly at this level. It is believed the machine is underfilling the bags. Okay, so what we're going to do first is we're going to say mu is underfilling is less than. The opposite of that is greater than or equal to. Okay, so we take the one with equality, and that is going to be our null hypothesis. And that was 449. I'm going to erase that one. So there's our null. Here's our alternate hypothesis. Since it's less than, it's left-tailed. All right, that's what it wants. If that's what it wants, that's what I'm going to give it right there. All right. So I can probably do this one without writing it down. Let me show you. And I'm sure you can if you work enough of these. So it says, it wants to know, it says, it is believed that the machine is underfilling or overfilling the bags. Whoa, so you're saying greater than, or it could be less than. Well, that means not equal to. If you're looking at greater than or less than, that's two-tailed. So if it just would have said underfilling, it would have been left-tailed. If it would have just said overfilling, it would have been right-tailed. But we have both of those, all right? I know that the machine can't do both of those at the same time. I would rather overfill my bag of chips, or chocolate chips. Ooh, yeah, especially chocolate chips. Anyway, it's two-tailed. All right. Now we want to find a test statistic, and this is the test statistic of a proportion. So we got to make sure we're using the right formula for the test statistic of a proportion. I'll go to the formula sheet and copy this over really quick. All right, so let's write down everything we have. So here's this is the claim here. But it wants to test the claim that the percentage is actually different. So this is P equals 0.49 and P not equal to 0.49. That's what that would mean if it's actually different. Random sample of 270 found that, and this is a sample proportion, so P hat, it found that 44% of the readers on the laptop. Find the test statistic. All right, so now I have to find the right formula. So I'll go to my formula sheet. Look at this. Test statistic for population proportion. There we are. So Z equals P hat minus P divided by sigma sub P hat. And remember, sigma sub P hat is the square root of P times 1 minus P divided by N. All right, so let's see what, I'll just copy that down so that I won't mess it up. So our z is going to be equal to 0.44 minus 0.49 divided by, now here's the main thing is that I get this sigma sub p hat right. And it is going to be the square root of p times 1 minus p would be 1 minus 0.49 is 0.51 over n, and n was 270. So you probably want to calculate that first and take it out to about, I don't know, 4 or 5 digits. That would be my suggestion. So I'm going to follow my own suggestion. Don't forget when you type in those numbers, you got to take the square root. All right, and so for the bottom here, this isn't the whole thing, but for the bottom part, I got 0.034229945. For the top part, I can probably do that in my head, negative 0.05. So I'm going to say negative 0.05 divided by 0.034229945. And remember, this is a z-score, right? So even though it's a test statistic, it's still a z-score. So let me see. All right, so I'm going to be honest with you. I just paused my video because I left out a 0 right here. So if you rewind for about 10 seconds, you'll see I had 0.034. I left out my 0. I didn't read my calculator correctly. So hopefully you can relate to me. These numbers start all kind of running together sometimes, so I apologize for that. But now I'm going to divide, and then I am going to round to 2 places. All right, so I got negative 1 point, if I round to 2, it's going to be 1.64. So make sure you negative 1.64. All right, so it looks like here we're trying to figure out either to reject or fail to reject. So this is one of those problems where let's see if there's sufficient evidence. So I'm going to have to write this down. So as I read through this, it doesn't give us a lot of information, so it must be worked out for us. Let's see. It says that the newspaper publisher believes that over 33% of their readers own a laptop. For marketing purposes, a potential advertiser wants to confirm this claim. After performing a test at the 0.02 level of significance, the advertiser decides to reject the null hypothesis. So if you decide to reject the null hypothesis, then that means that the percentage must be over 33%. So let's see what our choices were. So, well, either there is sufficient evidence or there is not sufficient evidence. Well, this person says that they decided to reject the null hypothesis. So that means there is significant evidence. So it can only be this one, regardless of what all this wording is over here. If you reject the null hypothesis, all right, then that means there is sufficient evidence that it's over 33%. All right. Here is another problem finding the test statistic. Remember, each test statistic is different. You have different formulas depending on what all you have given. It looks like this is percentages here, so this is going to be another proportion. So I'm going to need all this up here that I had. So let's see if I can copy that and bring it back on down here. So if I'm just going to find the test statistic. So we have a sample of 1,600 revealed that 75% of the chips fail in the first 1,000 hours of use. Okay, so that would be from the sample. So that's p hat. The company's promotional literature states that 73% of the chips fail in the first 1,000 hours of their use. So P is 0.73. These numbers are there just to throw you off. It says the quality control manager wants to test a claim that the actual percentage that fail is different from the stated percentage. Now, it didn't ask us about two-tailed and all that, but right tail, left tail, but it would be, it appears to be a two-tailed test, even though we don't have to know that. So we're just going to find this here. So my z-value equals p hat minus p over, and then it's this thing right here, the square root of 0.73 times 1 minus 0.73 is 0.27, and then that's all over n, and that's 1,600. Again, when you're working this out, don't forget to take that square root before you divide. So you probably want to punch this in your calculator and take it out to a couple of places. So all right, so now I'm taking the square root. Just imagine what it looks like. It's so grand. The numerator is 0.02. I took the square root and I got 0.011098986. So I'm going to divide that, and then I'm going to round to two places. All right, and if I round that to two places, I get 1.80. Not too bad, almost done. All right, this is one, determine the p-value, okay? So I'm going to have to bring that p-value chart back up for us. I'll copy this over. All right, and then I'm going to scroll up and get that p-value chart and copy it back down. It might not fit, but we'll try. Okay, that's not what I wanted to do. So I'll just move that down there. All right. Let's see, make it a little bit smaller. So, all right. So let's see. A publisher reports that 46% of their readers own a personal computer. A marketing executive wants to test a claim that the percentage is actually different. All right. So we'd say P equals 0.46. Different means not equal 0.46. So H sub O is the one with equality. H sub A is the one without equality. So what type of test is this? This is a two-tailed test, okay? All right, so this is not left-tailed. It's not right-tailed. So we got to go straight down the middle. All right, we need to know if the test statistic is to the right or left of the center, okay? So we need to figure out the test statistic to be able to figure out the p-value. All right, and it's the same formula we just used. It's C equals p hat minus p over that sigma sub p hat. So once we figure out this, we'll be able to figure out, we'll follow our little directions and figure out our p-value. All right, so we have n equal to 100, and we have p hat equal to 0.42. So we're just going to plug these numbers in. 0.42 minus 0.46 divided by, and this is the square root of, and we use our p-value here, 0.46 times 1 minus 0.46 is 0.54 divided by n. Okay? So I'm going to work that out. Got And again, don't forget to take the square root, because if you do, I guarantee you'll get a crazy answer. All right, so I have in my denominator 0.049839743. Yeah, that's a little extreme, but whatever. All right, so I need to see 0.42 minus 0.46. That's going to be negative 0.04. All right, so now I'm going to say negative 0.04 divided by 0.049839743. All right, and so I have negative, and if I round to two places, 0.80. All right, so that says, is the test statistic to the right or left of the center? All right, well, remember, z-scores on, let's see, the center is 0 for z-scores. Numbers to the right are positive for z-scores, and numbers to the left, of course, are negative. So ours is negative. So that means that our z-score is probably somewhere, if I just had to guess, I'd say about right there. It's not quite one standard deviation, so it may be a little too far, but that's okay. We have a z here of about negative 0.80. What do the directions say? If it's to the left, it says the p-value is twice the area to the left of the test statistic. So I just need to say 2 times, nobody uses that anymore, 2 times, and I got to find the area to the left. Well, that's the way our tables are made. So let's go to our table, and we're looking for negative, so that's table A, negative 0.80. Let's see, the 0 column is here, so negative 0.80. Okay, so I got 0.2119. So 2 times my age is going, so I have to look back again. It was 2119. All right, so 0.2119. I said my age, I meant my mind. That's how bad it is. All right, so multiply that in the calculator. And I got 0.4238. So that's my p-value. 0.4238. I'm going to double check everything real quick because I have a slight difference of answer. So I'm just going to type my stuff back in again and double check my values. Okay. I apologize for this extra time here, but I want to make sure I get the right answer. And I did get negative 0.80. And so I'm going to look one more time in that table. Negative 0.8, and then 0 is that right there. Correct. Okay, so if I say 2 times 0.2119, and that's the answer I got. My answer key says 0.4237, so I would assume it's still going to take this answer. If it gives us the wrong answer here, and for some reason you missed this problem, I'll just give you credit. I'm cool like that. 0.42. I'm gonna put 38. I'm gonna put my answer, and we'll see. All right, now last problem of the test. This is the real deal, the whole thing. We either reject or fail to reject the null hypothesis. There really should have been about 10 of these on the test, but I decided just to put one. So we could do the classical or the p-value method. I prefer the classical method over the p-value method. A mayor of a town proposed a plan for the annexation of an adjoining community. Political study took a sample of 1,200 voters in the town and found that, this is from the sample, 54% of the residents favored annexation. Using the data, a political strategist wants to test a claim that the percentage of residents who favor annexation is more than 51%. So first I would say P is more than 0.51. Then I would say the opposite of that is less than or equal to 0.51. Then I will say equals, from the equality, that's going to be equal to 0.51. All right, this is my null hypothesis, this is my alternate hypothesis, and this one disappears. Make the decision to reject or fail to reject the null hypothesis at the 0.02 level. 0.02 level. All right, so again, I'm going to need to calculate the test statistic. And you may be asking why. Well, I even though I do prefer the classical method of using the test statistic and a critical value, since this is a proportion, the easiest way to do this is going to be by using the p-value method. And so this is a greater than, so I can already tell that this is right-tailed. So I'm going to find the test statistic, the z-test statistic, by using that same formula. It was p hat minus p over the square root of p times 1 minus p would be 0.49 over what? Over 1200. I'll show you why it's going to be easier, because we've been doing those types of problems, so we can probably do this one pretty fast. So 0.51 times 0.49 divided by 1200. Remember to take the square root. All right, so my denominator here is 0.01443087, and my numerator looks like it's going to be 0.03. So let's divide. Okay, so if I typed in everything right, I have a z-score of 2.08 if I round. Okay, so here's how the p method works. Once we find the p-value, then we'll compare it to the significance level. All right, if it's less than the significance level, then we will reject the null hypothesis. If it's greater than, we'll fail to reject the null hypothesis. So it's not this, it's the actual p-value. So how do we find the p-value? Remember this table up here? If it's right-tailed, which it was, we figured that out from the alternate hypothesis, the area to the right of the test statistic. We figured out the test statistic was 2.08. So I'm going to go to my chart, and I want to find the area to the right of 2.08. So to do that, I say 1 minus whatever I'm about to find. And here's the 8 column here. So 2.08. So that's 0.9812. 0.9812. So I'm going to say the p-value is equal to 1 minus 0.9812. I'm going to double check. There it is, 0.9812. All right, so do that in your calculator. 1 minus 0.9812, and I got 0.0188. Okay, so you tell me, is 0.0188 less than 0.02 or greater than 0.02? Of course, we can all figure out that 0.02 is bigger than 0.0188. So if the significance level is bigger than your p-value, you will reject the null hypothesis. All right, and that's what we're going to go here and put. Reject null hypothesis. I'm interested to see what I score, because remember on that previous problem I was off by 1/10,000th. So let's see. All right, so submit. Yes, submit. All right, it says that 27 out of 28. I bet that it is that one problem. And if it is, if you get this, if you get the numbers that make you miss that problem, then I'll just go in and I'll correct it. But we're going to double check. So I bet you it is, and it was probably, there it is right there. Guess what? I typed in something wrong. It wasn't that one, so it doesn't matter that it was off by 10,000. And you probably saw me do that in the video. The key on this keyboard I use sometimes will just put in extra numbers there. So, you know, if you ever make 1,000 on a test, it's probably because that extra number got put in there by the keyboard. I deserve to miss this problem. If you do something like this, you know, email me about it and I'll give you credit because, again, I'm cool like that. Anyway, that is the end of your test 1 review. I'm sorry, test 4 review. I already have your final exam review out. I would watch this a couple of times and then I would practice the review, see how you do. If you have any questions about anything, feel free to give me an email. I'll help you any way I can. I want to see you succeed. I want you to make good grades in this class, whether you believe me or not. I do. All right. I judge my teaching on how good you do. Anyway, have a great day, and I hope to hear from you soon.